So yeah, so this is week 2. I'm going to go ahead and share my screen and we can start talking through what we're going to cover this week. I know many of you have already started training, so that's great. We'll talk a little bit this week about just like sort of, maybe you were thrown into training and weren't sure exactly what you were doing with a lot of the settings and those sort of things. So we'll talk through sort of the process of training as well as a bunch of the settings and parameters that you can be editing when doing a training. And then we'll also look at a bunch of things to watch out for during training. So we're going to cover just sort of like a bunch of the pitfalls and issues that can arise when training. And then I think at the end, we'll talk a little bit about just sort of like how to check on training and that sort of thing. So this week is really just going to cover pretty much everything that you could imagine about training. And then next week, we'll be covering a little bit more on inference, and we'll also do a little bit on sort of a special. So StyleGAN usually only works with sort of like what we call one domain, which is like it's all faces or it's all cats or it's all, one category of things. There is a way now in the newest version to start working with sort of different what we call class labels. So that could be a common thing you'll see inside of machine learning is I would like to train a model to generate numbers, but I want to be able to specify I want a number 1, I want a number 2, I want a number 3, I want a number 4. Or another case of I've got different types of animals I want to generate. So we'll look at how to do that next week. Yes, and then probably this week we'll start sharing just sort of like our one-on-one schedule. So we'll post some links in the Slack channel. You can go ahead and sign up for a one-on-one with us. It's up to you whether you want to do one of us, both of us, whatever. We're sort of like, we don't really check. So you're welcome to sign up and talk to both of us if you want to. Those are good sessions if you have specific problems or if you are specifically working on something and you want like, a little bit of help directly involved in those. You're also welcome to bring those issues to our co-working sessions. But this is good if you want to like schedule a specific time or maybe those co-working sessions aren't as great timed for you. So you want to set up a particular time to work with us. So yeah, we'll send some links out for that this week. And then lastly, I wanted to sort of gauge the vibe of the room. We've previously done sort of show and tells. So this would be something where maybe 2 weeks after class is over, which is obviously next week already. So maybe like early November, we would do something where everyone would come back together and sort of show what they've been making. In the past, we've done these live streamed over YouTube and invited a bunch of people to just come check them out. They're pretty low key. They're totally optional. You don't have to present any work if you don't want to. But I think they're like a fun little way just to sort of show everyone what you've been working on and also like, get your name out there a little bit if this is something you want to do more of. So maybe we can just post like some a follow-up sort of poll to gauge people's interest in this at the end of class. Does anyone have immediate thoughts on this at all?
So for the show and tell, you mean?
Yeah, definitely, yeah.
So I did it for runway class back in April, and I thought it was a good way to kind of like conclude the course in general, just because all the other ones, like I just took the Dataset one and then Google Colab before that, and they're both shorter. They were both shorter courses, but it was just like, okay, this is the end of class, and it kind of felt weird, even though we're like I was rolling into another course, but it was just nice to be able to have some sort of presentation, like a low-key presentation, and be like, well, at least I produced something, and it's like some kind of motivation.
Yeah, and they're also, I mean, that's a great point. I think it's also a great opportunity to use these one-on-ones to sort of like talk through what you're working on, and maybe we can also give you additional help on things. And I think Lee and I are probably thinking about doing it, we haven't really figured out the schedule yet, but, something like not just like immediately the week after, but like give you an extra week of time to really like jam through some stuff. Cause I know next week we're going to actually talk about how to generate images and video and that sort of thing. And you'll probably want a little bit of time to both do some training and play with that. So it wouldn't be immediately after, it would probably be, 2-3 weeks. Probably sometime in like early to mid-November. So we'll talk about the schedule. Anyone else have additional thoughts Naoko was really great in sort of suggesting this to us previously, and I think it's a good idea, and it's a great way to motivate people to make some work.
I totally need that pressure, and I've done it before, and I think it was great. I mean, I just like, in my opinion, the best way to narrow down the class and get the most of it is to do something, even if it's not a super cool project. So I mean, company, I need the pressure to get things going.
Cool. Yeah, that sounds great. Yeah, so I think Lee and I will talk again this week and sort of set up some time. And we might put out another poll just to see what time works best for people, because I can imagine a show and tell at this exact minute for some of our folks in Europe might not be the most fun thing. So maybe we'll shift the time around a little bit for people. So Lee and I will discuss that a little bit more, but glad to hear there are already some people interested in this, and we'll talk through it a little bit more. Cool, so keep an eye out for that. We'll post some stuff in the Slack channel when we get there. Cool, so I'm interested to hear, I know I talked to a bunch of folks this week, and I know a bunch of you are probably doing collab. I know a couple other folks have like sort of their own setups. I'm just wondering, for anyone who wasn't able to chat with us during co-working, how did setup go, both in either in Paperspace or collab or whatever else you're working on? Did anyone run into any issues that they want to bring up now or just talk about?
Hi.
Hey there.
Yeah, I got a problem with Paperspace. It's been stuck on loading your desktop. Your desktop is connected forever.
Did you try, I've also run into this issue. Did you try going back to the console and then reopening the desktop and seeing if that did anything?
Reloading. I tried reloading a couple of times.
Okay. Okay. Maybe you can set up some time with Lee or I, and we can try to walk you through that, because I've also experienced that as well. And it is like, it feels like there's a weird like trick there. Like maybe we need to restart your machine or something. So yeah, if you could just reach out to us, maybe one of us can work with you to get set up.
Okay, cool. Thank you.
Either by show of hands, or if you just want to drop a note in chat, who is using Colab for this class? Okay, cool. So most people are going to be on Colab. Anyone using, so I know you're using Paperspace. Anyone else on Paperspace? Okay, Michael, cool. Okay, yep, great. Okay, cool. So we've got a couple people on Colab, a couple people on Paperspace. Is anyone else using anything else? Matt, I know you've got your own system set up. I think Quinn, you said you were also going to set up your own rig. Anyone else doing something else that I haven't mentioned yet? Okay, cool. So that's great for me to know. I am trying to record videos for everything in both Paperspace and in Colab. And obviously anything you do in Paperspace will translate pretty easily to if you're doing a GCP or your own rig, it should work just fine. So that's really helpful to know. So I'll definitely make sure that we keep doing that as we go forward. And also like, I might try to record a video this week just about like, if you're interested in either converting stuff from Paperspace or like terminal code to Colab or vice versa. Because sometimes I'll do notebooks for things and people are like, how do I translate this into using it in my own system? And sometimes it's easy and sometimes it's hard. So I'll try to record some additional materials around that. Cool. For those of you who are training now, excuse me, I highly suggest that, I know Matt was already dropping images of what he trained and what he was working on in Slack. I know Will did it earlier as well. If you are training stuff, or throughout this week, if you're training stuff, please post it in the Slack channel. Everyone loves to see what people are working on. There'll be lots of questions around how big your data set is, what your parameters are, those sort of things. I just think, again, it helps sort of motivate people or get people interested in sort of seeing what everyone's making. So definitely encourage you to keep using the Slack channel for that. I'll try to also post some new materials. I did about, God, I trained probably like 6 or 7 models over the past week, just trying to learn how all this stuff works in this new fork. So most of this class, I'll be talking through sort of my own experiences, and there'll be some things that I either didn't get to, or I'm planning on getting to, or I've just started to get to, and I'll follow up with more detail about that as well. So definitely want to see what people are working on. And if there are things where you're like, hey, this thing didn't work, that's kind of great because I would love to try to figure out how to improve that. And I have some ideas on how to improve things, but we might just want to work together one-on-one to help with each model. So please feel free to post stuff. If you're running into issues, like definitely post stuff in there as well. And Lee and I can get to that and try to help you through things. Cool. So I'm going to start a little bit of this class just with talking about if you've noticed that the fork or the version that we're using for this class is called StyleGAN2-ADA. And I want to talk a little bit about what the ADA stands for and also just like a little bit of a history of StyleGAN, because I think understanding a little bit of that will also help you know about like sort of the new parameters we're going to be using during training. And it'll help give you a little bit of a better sense of trying to like keep an eye on certain things. So I mentioned this in the Slack channel last week. In our class notes, I added all of the links for the StyleGAN papers. So StyleGAN1, which is just called StyleGAN, StyleGAN2, and then the latest one is called StyleGAN-ADA. There's actually one paper even further back from that, which is called Progressive Growing of GANs. And that is sort of the early precursor to StyleGAN. All 4 of these papers were written by the same team at NVIDIA. And basically like every year, I think almost every October actually, they release this new paper. And it sort of is like an updated version of it. So I know for some folks, you're just interested in making stuff. For other people here, you're more interested in the technical ideas behind everything. If you're really interested in the technical ideas or just sort of like understanding a little bit of how machine learning works, I recommend reading these 4 papers, either in order or just like start, pick one and just read it and then pick another one. If you've never read machine learning papers before, they can be a little dense. There's a lot of math in them. There's a lot of terminology that is like, honestly, that I still don't even understand a lot of times. But I do find that if you sort of like just gloss over that stuff and read the rest of it, that it is sort of helpful and gives you a good sense of things. These particular papers also have a lot of good graphics, which I think can also help you understand various pieces of it. So, this is 4 or 5 years of GANs, and maybe like, I'd also say these are probably like one of the more popular papers, as well as like probably the most innovative each year almost. There's maybe a handful of others that are more interesting or contributed a lot to the space. But if you read these 4, I think you'll get a good sense of just sort of like how the technology has moved and that sort of thing. So if you're interested in that, I definitely recommend reading it. If you have questions about it, I can help if I can. I am definitely like not going to say that I understand everything going on in those papers, but I'm happy to walk through them if people are interested. Here's an example of sort of StyleGAN 1, StyleGAN 2, and then the latest StyleGAN ADA paper. So you can see in the past 3 years, we've really changed a lot in terms of like what's available to us. The very first version of StyleGAN 1, when I first did my first training with this data set, I was like, oh, this looks really, really good. And then StyleGAN 2 came out and I said, wow, this looks really, really good again. Like it's so much better. And now this latest version is out and I'm like, wow, this looks even better. So, again, almost every October, like clockwork, there's a new version of this paper. I expect next year there will be a new one that maybe is even better. Who knows? So I just think it's really, really interesting that these things continue to change. And getting in anywhere at any one of these points and sort of understanding what's going on will help for the next version and the next version and the next version. So, I certainly got in around this level and I thought I knew everything about it. And then every time a new paper comes out, I'm like, oh, I have no idea what's going on and I have to learn all this new stuff again. But the results are really, really amazing. And I think they're only going to get better over time. And it's kind of an exciting moment to be playing with a lot of this stuff. So I'm sure that's why all of you are here, but I just wanted to point out like this stuff is really, really improving every year. And even when Lee and I taught this class in, when did we teach in April? Even then it's been like so different just between now and then. So there's a lot of stuff going on and it changes very quickly, which can sometimes feel really frustrating, but can also be really exciting sometimes. So yeah. So you might be wondering why we don't call the newest version StyleGAN 3. And it's not really my call to make, it's sort of the people who created the network and that sort of thing. I would say they're not calling this StyleGAN 3 because the new paper really doesn't change the architecture of these platforms. So if you remember, we talked a little bit about this last week. There's all these different layers in each network, right? So there's the generator and there's the discriminator. Each layer within those, moving from StyleGAN 2 to StyleGAN 3, there really aren't a lot of changes. We'll look at a couple places where there are some changes or places where they're sort of making options, but the reality is there's not a whole lot of changes going on. What is being changed a lot is how the actual process of showing images to the discriminator to choose whether they're fake or real. What's going on behind that process is a lot different. And that is this thing called ADA, which we'll talk about in just a minute. So again, the architecture isn't different, but the way in which an image or the discriminator is seeing images that are real and fake is. And the reason for that is that in small data sets, and when we talk about small data sets, we're actually still talking about pretty large data sets. We're talking about 1,000 images all the way up to like 30,000, 40,000 images. Remember that NVIDIA's FFHQ data set is 70,000 images. So the previous versions of their networks were built with 70,000 images of very similar domain, faces, were built with that in mind. And now this newest version is sort of saying, okay, well, what do we do to make this better for smaller data sets? And the problem with smaller data sets is that, if you've got 1,000 images and you're cycling through showing that to the discriminator over and over and over again, what researchers found happens is that the discriminator basically memorizes those images. It says, this is always what a human face looks like, or this is always what a plant looks like. And memorizing actually for discriminators can be problematic because if you just memorize things, anytime you show something that is not exactly that image, the discriminator says that's fake. And what that can lead to is it can lead to the generator either not really learning or not really producing better imagery, or the generator almost generating sort of tricks and hacks. These are usually called adversarial images, which is the generator will generate an image that it figures out, fakes out the discriminator, and sort of stays in those areas. And a lot of times that really hurts the generator. It means the generator produces very sort of similar images. Either it memorizes its own level of generating images. All this process happens much more frequently with small data sets. So the way that the people who created the new StyleGAN model were able to solve that is through a thing called augmentations. And augmentations are, we'll show some examples of this. Augmentations are things like rotating images just slightly or scaling up the images a little bit here and there. There's a lot of different techniques that people have used. And the truth is augmentations are used a lot in classifier networks. So when you train something like, if you were in my previous class, the datasets class, when we made a YOLO network, an object detection network, augmentations are a huge part of that process. And this makes sense because the whole point of a classifier is to look at an image and say, that's a cat in that picture, or that's a human in that picture. And the truth is, if we see, speaking of cats, if we see, right on cue, if I show you a photo of a cat, but it's behind a couch, and you're only seeing half its face, you still want the model to be able to say oh, that's still a cat. Or if those classifiers only ever seen cats that are standing straight up, and then you show a cat laying down, you still want it to sort of know hey, that's a cat. So augmentations have been used as a way to sort of create additional imagery or additional data for a classifier network to say that's still a cat in that photo, or that's still a goat in that photo, or a sheep in that photo. So what we're doing is we're starting to bring that now to GANs, and we're trying to figure out the right way to do that. And here's a couple examples of just sort of augmentations that are used in the wild. These are some that are used by the YOLO network. So you'll see there's slight rotations, but also a scaling back of that image. There are some things of, it's maybe a little hard to tell, but here's stuff maybe the image is flipped. Maybe we're doing some saturation or desaturation of images, right? Because again, we don't want people to only know, or the model to only be able to tell a cat if it's perfectly lit, right? If it's in a grayscale photo or the lighting is weird, you still want it to be able to recognize it's a cat. There's also some more advanced techniques, which you'll see here on the right. Mix up is sort of mixing up a bunch of different images. There's a thing called cut mix, which is basically cutting out images and putting in new things. Mosaic, right? Again, if there's if you show a collage of things, you still want to be able to detect where the monkey is in that photo. Blurring, that's again a thing that if an animal is moving really fast in a video, you still want to be able to track it. So all these techniques have been used as ways to create better classifiers. And the challenge has always been to bring those to GANs is that we can't really just create a bunch of generated images, right? We can't generate images in our own data set and then feed that to the model, because all that will do is it'll spit back blurry cat photos or weird collages of cat photos. And we don't really want them to come back as that. We just want it to be able to train using those. And the real challenge of what ADA does really well is that it's found a way to sort of do that in the training process, but not have it affect the generated process. So what happens is, this is what I believe they call differentiable inside the paper. And what that means is that there is a process so that at the time that the discriminator is looking at images, it is doing augmentations to both the real and the fake images. And usually like sort of the same process to those. It's then saying, based on this process, which of these images are real and fake. And then it's got a way to mathematically undo those processes to actually train the generator. And that is sort of the big leap that this paper gives us. And actually, when this paper first came out in June, there were a couple other papers that also sort of reached at the same time, all the same ideas, which is that basically we can do augmentations, but the challenge is we need to figure out how the augmentations don't affect the generated output. And there's been a couple different papers that sort of explored those areas. So here's sort of an example. This is directly from the StyleGAN2-ADA paper of sort of how this process works. So you'll see here that there's augmentations going in, and then at some point there's, I believe this negative f of x function is the actual removing of these augmentation processes. But that those are then the loss function, or like however, like, hey, how far off was this guess, is then trained or like figured out after that process has been removed. So there's some examples here along the right-hand side here. P is a probability score. That is how often the image has the likelihood of being augmented. So you'll see at 0.1, a lot of the images look pretty tame. They're pretty similar. When you get to P equals 0.8, which means 80%, there's an 80% chance of them being augmented, they get really, really crazy. And it's important to note that like what's actually happening here is not just one single augmentation at a probability of 0.8, but that all of the augmentations possible are at a probability of 0.8, meaning in some cases you get rotation and shearing and coloring and other things. And then in other cases, you maybe just get one or two of those augmentations. So this is sort of the groundbreaking part of this paper. And it's also why we end up with like much, much better results. And it's like still a little bit hard for me to wrap my head around like how you can undo a transformation and have the generator still learn from it. But that's the idea going on behind this. So part of the challenge here is that you want to keep that probability low, because if the probability is really high, so say we're only ever showing the model images that look like this, that will do what the paper calls leakage, meaning that these concepts or these images leak into the generator, meaning the generator starts to produce images that look like these things. So the challenge here is that you need to sort of like figure out a good probability score where the generator and the discriminator learn enough, but it's not leaking into the process of actually generating the outputs. And as you will see, the paper claims they do a lot of good job with removing these. In my own tests, I found that it's not as good as I would like it to be. And we'll look at some examples of how to fix that. But it is something you want to keep an eye on, because you know, some of this can leak into your generator images. So you want to make sure it doesn't, because that will lead to a lower quality image production. Let's see, I feel like I skipped a slide here, but anyway, you know, just the big challenge here is like, the big thing to think about is like, this is all done internally inside the model. So we don't really ever see a lot of the outputs. There are ways you can export the outputs from this, or like watch it in as it's generating, which I tried to get set up on my local machine and it was kind of a disaster. I might try it again this week and try to see how it goes. But that's the idea, is that the generated images in your data set are still really, really clean and perfectly produced, or like a really clean data set. And then all these augmentations are going on inside the model as it trains. And then your output should still be really clean, really realistic producing outputs. Any questions from that? Okay, cool. So I'm not going to go through an entire demo of training in this, because it's honestly like probably like a 30-minute process in and of itself. The basic process for this, if you haven't done it yet, is you're going to upload your data set. So if you're in Colab, you're going to upload your data set to probably Google Drive and then sync it over mounting your drive. If you're on Paperspace, you'll just figure out a way to get your images into the Paperspace server. Again, I'd probably recommend something like Drive, because it's a fairly easy process to drag and drop into your desktop view. You need to convert that data set into an image format that StyleGAN works with. This is called TF records. So there's a script you need to run. that can take anywhere from like 5 to 20 minutes, depending on the size of your data set. Once you have that done, you only ever need to do that once per data set. So no matter how many data, if you have like, one data set, if you're going to train it multiple times, you don't need to do that conversion more than once. If you have multiple data sets, for every data set, you want to do that conversion once, and then you can train off that no matter what. So once you have that done, you'll then run your training commands. We'll talk a lot about like the exact commands you want to run, those sort of things. I'd recommend if you have not yet done a training session and you feel like a little uncomfortable with it, come to one of our co-working sessions this week to have Lee or I help you walk you through it. I would also say like you should just dive in, and if you break stuff, just DM Leah and I, and we're happy to walk you through it. You can't really break anything too badly with this setup, so we can help walk you through those things. And then once you're training, training is actually much faster with this newest model than it was previously. I used to recommend like, hey, don't really check on it for the first couple hours. I'd say now, like especially if you're in collab, like you can check within an hour or two and you'll start to see good results, which is really amazing. The training process is way faster than it used to be. So it's really nice. It actually will make this class much easier than it was previously. But you will want to check on this every once in a while, and Leah and I will talk about that at the end of class as well. All right, so first off, if you're in Colab, I know I linked to this already in the Slack channel, but there is a Colab notebook already set up that will walk you through this process. Whoops, let's see. So I definitely recommend just opening this up in Colab. I don't have a video yet. I'll probably record a video either tonight or tomorrow that walks through this process, but there should be a good enough amount of notes here in the notebook to walk you through it. So if you haven't done it yet, take a look at it, read through it. If you have questions, please let Leah or I know. I will be recording a video for that. I just haven't gotten to it yet. I did, however, just today record a video on training inside of Paperspace. So if you are using Paperspace or if you're using your own server, these are sort of the steps and the processes you'll want to walk through. So this video will walk you through it. I think it's like 35 minutes long, but I try to explain like every detail in like full, as much as possible. So give that a watch, and if you still have questions, let me know. So for the actual training process, I recommend both of these pieces of materials, but I don't go into the details of all the different training parameters you can use. So that's what this next 45 minutes or so is going to be for. So take a look at those if you haven't started training yet. And again, let Leah or I know if you have questions. I should also note that this is most of the training parameters I'm going to go through are in my fork of the repo. I think I linked to it already, but if I didn't, I will drop a note in our class notes to just let you know that we're going to be using my fork. Part of the reason we're going to use my fork is the NVIDIA folks basically like do what they refer to as code drops, which means like they drop all the code and then they never touch it again. So there's often bugs and there's often other things that need to be fixed, or just like additions that I have found really, really helpful over time. I've started adding to those now, and I will continue to add to them as we go forward. So I may let folks know in the Slack channel or in other places that like, hey, I just added a bunch of new features, so go ahead and use git pull to update to the latest. If you're in Colab, I'll do a video on how to walk through that process. You still do a git pull, but it's kind of confusing because you have to do it within Drive, which I find that it's like one of the crazy like mind bending things is like you have a Git repo sitting in your Google Drive account and you're using Git off it. But I'll let you know how to do that. It's pretty straightforward. But yeah, just know that like some of the things that you'll see me talk about here do not exist in the official NVIDIA repo because I've been adding things and I've had friends who are adding stuff right now as well. So this will be especially true when we get to inference. I have a ton of different materials to generate different types of loops and different types of imagery that the basic NVIDIA repo does not. So just be aware, like, you should probably be working off that one if you're not already. Okay, so as of now, there are really only two required training parameters. And those are your outdoor and your data. So if you watched any of my previous, I think I've linked some of you to the previous StyleGAN deep dive that Lee and I taught. And there's a whole like week 2 is also like all of the parameters. Pretty much none of those parameters work in the new model. They like kind of did this thing where they renamed all the parameters to make it easier. But if you've used any of the other models, it's actually harder now. So just be aware if you've seen that video, like maybe you need to check to make sure that these things still exist in this new version. But when you're running your training parameter, there's only really two required things. The first one is outer, and data. Outer is really like, where do you want your results to go? I believe that they sort of call like their example files, I'll say training runs as the output folder. I like to call it results. I think results is much clearer as like what's in there. So this you only need to set basically once when you're running the training command. And I recommend always setting the same. Otherwise, you end up with like weird folders all over inside of your repo. So make sure that whatever you choose, you just want to keep it consistent. I definitely recommend that something like /results is like a pretty straightforward way to approach it. That's probably what you'll see me use in most cases going forward. And second, you need to provide the link to the data set. So in the process where you're creating, converting your images into TF records files, that will create a path that is a datasets folder. And you need to pass that into the training command. So --data. And then it'll be something, if you're following along with videos that I produce, it'll probably be something like /datasets/ whatever the name of your data set is. So that's it. There are only two required parameters. That's very different than previous times where there was like a data set folder, there was a data folder, there was like all these other things. So it's actually pretty similar to just like start running. Now the truth is like, I never just run it just like that. Here, as of today, all of the optional parameters that you can run within this model. This looks like a lot, and it is a lot. And what I've sort of done is anything that has an asterisk by it in this is probably like a thing that I actually use pretty frequently myself, meaning you probably don't need to worry about the other ones. I'll cover them, but you probably don't need to worry about them too much here. I'm just going to do a check on see where we are on time. Cool. All right, so I'll get started with this, and then we'll probably take a break, and then we'll come back and pick up on some of these. So the way to find these, if you're ever interested, or if you ever like 6 months from now want to see what else I've added that I haven't covered in this class, is you can run the train command. So there's a training script called train.py. So you'll run Python space train.py and then --help, and that will spit out a ton of stuff to your output of like, here's a bunch of example scripts. Here is a bunch of parameters you can use. Here's how each parameter is described. So I've left that, I think, in the notebook. And I definitely recommend running it every now and then just to like double check and remind yourself what each of these things means. I've broken these out into sections that the NVIDIA repo itself breaks them out into. And anything new that I've added, I've sort of added into the categories that make the most sense. So I'll walk through these sort of like top to bottom, left to right, and we'll just sort of go through them one at a time. I'll try to highlight the ones that I think are really important, and then I'll try to highlight the ones that I think are not important at all, and then the ones that I think like maybe depending on what you're doing is something you want to keep an eye on. All right, so --GPUs. I think most of us will be working off one GPU, so we don't really need to worry about this. The default for this is one GPU, so you don't really need to touch it unless you're using multiple GPUs. If you are using multiple GPUs, let me know, but it's really pretty straightforward. Snap. So this is kind of one that you kind of get a good feel for after training for a while. So what does --snap stand for? So that stands for snapshot. Basically, the idea is that as you're training, you don't want to just like let it train the entire way through like a week and never see the results, right? So a snapshot is basically at some point while it's training, it takes a snapshot, which means you get a fake image file, which is a grid of images, and then you also get a pickle file, which means your model file. Now, the challenge sort of here is that if you run snap every single tick, you will get a lot of files, which is maybe fine if you have a really, really big hard drive. But it can also just feel like it's a little overwhelming. Like you get a new fake image and a new pickle image every 4,000 K images. So I generally say like, I think, around 2 or 4 is a good number. I think the default in StyleGAN is 50, which is insane. That's way too high. That means like every like 12 hours you'll get a new pickle file, which is too much. So I definitely recommend, trying 2, 4, 8, something like that, because that is going to give you just a couple, like a file every hour or a file every half hour, which is I generally find like kind of achievable and understandable. We'll talk a little bit more about how to read the fakes and how to sort of interpret like, are these good or are these bad, that sort of thing, just a minute. But just know the snap setting is sort of what you want to do to play with that. So I would almost say the snap is almost required because the default is 50. You should always be passing the snap value because if you're not, like, you're going to wait forever before you actually see results from your model, and that's like no fun. Seed, I don't really change this. I don't think you need to. this changes the seed values or the randomized seed values of your grid of images for your fakes. So you'll see that as you generate your fake images, every one of them looks pretty similar and there's slight shifts in those images. If for whatever reason you're like, I'm sick of looking at these images or I just want to see some different diversity, you can change the seed value. I think the default is like 1000. If you want to change that to just generate new fake images, you can. But it's almost counterintuitive because you should almost really be looking at how individual images are changing over time. But if for whatever reason you're just like, I don't think these are the right seed values, you can change that. Okay, resolution. I haven't figured out why I would need to set this manually. There's a automatic configuration where it goes through your data set and tries to figure out the size of your image data set, and it sets the resolution based on that. There might be some way, I have seen some people talking about there might be a way to feed in a data set at 1024, but output it only at 512. I wouldn't necessarily like recommend anyone plays with this unless they have a really specific need for it, because there is an automatic setting within the configuration file to do this. Mirror and mirror Y. So mirror Y is one that that was like the very first thing I added. So mirror and mirror Y, I think we talked about this a little bit in the datasets class, but StyleGAN, obviously like one really good way to pad or maximize your data set is, especially if it's like thing about faces or other things, you might mirror left to right, right? Faces are not that different left to right. So the idea of flipping them left to right is actually like a nice way to say like, these are still acceptable faces, but don't, you don't have to do it manually, right? So it can happen directly in StyleGAN. I've also added the ability to do top to bottom flipping. It's far less common that you do top to bottom flipping. But if you have like really abstract images, I find setting both mirror and mirror Y is good. So just like, again, it creates more data than you need. It's necessary. So these are both true false values or 0 1 values. So 0 is false, 1 is true. And in Python, you usually set true and false with a capital letter. So it's capital T R U E, capital F A L S E, or 0 and 1. Either of those work. And I should note, this is separate from the augmentation setup, right? So augmentations are doing their own flipping of values or own flipping of images and that sort of thing. This is to say it's okay if you output generated images that are flipped or generated images that are flipped top to left, top to bottom. So this is almost like, imagine you could actually do this using like datasets tools, like you could actually do mirroring directly in like and generate a larger data set. The problem is that then your output or your TF records files are like double the size and they get really, really big. So you sort of like don't want to do this by hand because it just makes larger files that are then harder and fill up more space. So doing it directly in StyleGAN is actually probably a safer and better recommended model. Let's see what time we're at. Okay, so let me cover metrics and then we'll take a break. Okay, so metrics. I go on many, many rants about metrics and how metrics force us as artists to like overthink all of our models. I'm kind of backtracking a little bit on that, as I always do. I always start really aggressive and then people are like, really? And I go, well, I guess maybe not. Okay, so metrics, I would recommend, I think I'm still recommending turning off metrics. The reason for that is depending on the type of GPU you're on, this can get really, really slow. So the default metric is a metric score called FID. And FID, if anyone's interested, I'm happy to link to papers that talk about what FID does. FID basically tries to score your images, your generated images compared to your results and give you a metric score. Usually it's between some like 0 and 300. And the higher the number is, the less real or the less like your results data set it looks like. The problem with that is that it's based on pre-existing models, meaning it wants things to be objects, it wants things to be faces, it wants things to look like things that have already had an object detector built around them. So if you have abstract images, your metrics are not going to really represent what's like actually realistic. And I tend to find that people get really obsessed with their metric scores. Like if you have a metric score of 50, you're like, oh, I need to keep training until it gets down to 30. And you keep training until it gets down to 10. Or like you'll see that like the high FID score for faces and FFHQ is like 3. And you're like, well, why isn't my model to 3 yet, right? So like you can overthink it a little bit much. So it also adds, if you're on a P100 or a P5000 machine, so that's Paperspace or Colab, I think running the FID score takes about 45 minutes to an hour. So if you're on Paperspace and paying by the hour, that's a very expensive task to be running, and it runs per snapshot. So basically, if you're running it every 2 ticks, That means every 2 ticks, you're going to blow through an hour of extra time, which is, again, like pretty gnarly. I wouldn't recommend doing it. You can run metrics after the fact if you're interested in just sort of seeing what the score is on an image, on a data set or a model you like. But in general, I would probably skip metrics. If you're interested in learning more about them, I'm happy to talk through them. But my general recommendation is just like, we're all artists and we can use our eyes to sort of see if we think something is better or not. And some of these scoring methods kind of, they're not as accurate as we want them to be or as we think they might be. So you can set metrics to equal none, and it will just like skip metrics entirely. And I think that's what I do by default in most of the notebook as well as in Paperspace. So if you want to do that, you're more than welcome to it. Here's a list of all of the potential metrics you can run. So the default is this FID 50K full. These scores are based on V100s. And if you don't have a V100, like you can only get a V100 through Colab, and it's kind of hit or miss. It's like 50-50 chance of getting one. If you don't get a V level, it's a P series machine, which is actually like triple the time to run this. So just be aware of that. That's why I sort of am like hesitant. One thing to note is that the paper says it actually thinks this is the best metric to run. So I don't know why they didn't set this as the default. They set this one as the default, but then in the paper they say, we really like this score as the best way to score things. So I haven't actually tried to run this yet. I might try it in my next run just to sort of see what it's like. If you're interested in this, this is probably the one they recommend. It takes about the same amount of time. It's just a slightly different method. There are a ton of different methods in here. Every paper goes into a ton about scoring. So if you're really interested in scoring, you can learn more about that. People have written a lot of stuff around like why FID sucks or why, you know, inception scores don't work, those sort of things. Lots of information about there. The way to actually set this is through, it is set through this one. So if you want to set metrics to equal something, you set it equal to a string value of this, and I believe it can be comma separated. So if you want to run multiple tests or multiple metrics, you can do fi 50k underscore full comma kid 50k underscore full whatever. Just know that like if you add multiple metrics, you're running all those times sequentially. So if you were to run all 4 of these metrics, it would be, 30, 50, an hour and 15 minutes, assuming you're on a V100. So just be aware of that. There's also a way to run metrics against a set aside default data set. This is pretty common in non-GAN machine learning work, where there's a training set, a test set, and a validation set. This is sort of the test set. I actually haven't tried this. I can understand why it might be valuable for like scoring purposes, but I would imagine for us it's kind of more work than necessary. But if you're interested, that's what metrics data does. You have to pass it I believe a TF records file to a offset setting of data. Okay, cool. So config is going to be a while. So why don't we take a break now? So let's do a 5-minute break. So if we come back at 53 after, we'll pick this up from here and we'll keep going. Cool. All right. So see everybody in 5 minutes. All right. Before we jump back into anything, are there any questions based on what I've shown so far? Realize this is like very academic and just like, here's this value, here's this value.
For the mirroring one, does it arbitrary mirrors like some of your data set, or does it mirror the whole, like your whole data set?
So basically what it does, it takes, there's a 50-50 chance every time it shows that to the discriminator that it is mirrored. So it basically mirrors your entire data set from like a conceptual standpoint. And then at runtime, when it's showing those to the discriminator, it basically flips a coin to say like, should I show this mirrored or not? Any other questions? And I should also say, there's a 50-50 chance of it being mirrored left to right. And if you have top bottom turned on, there's also a 50-50 chance of it being top to bottom. So it means there's what, a 25% chance that it's both flipped left to right and top to bottom. Yeah, those are additive, yeah. Cool, so I thought, I realized this is like very, maybe it helps to sort of see how you actually build up one of these commands in something like Colab. So this is the Colab notebook that I've sort of shared with the class. And you'll see that what I've done is I've broken out most of the major configurations into single lines. I know for some folks, this is an easier way to read it, just so it's like you can turn things on and off. And then when you run this cell, it like combines them all into this individual single line here at the bottom. But if there's stuff that isn't listed here that you want to add, you can either like you can sort of like follow my pattern down here, or you can write your own. One way to do that would be, you know, to take this command and just sort of clean up what you see here, which is, you know, so here's outdoor, here's snap. So if I want to set my own snap count as I'm writing this command, I could just set this to 8. Data is what my data set's name is. Let's say, you know, it's prints 1024. Mirror equals, this is the case of where, one second here. This is the case of where you want to do true or false. So it's true. Let's say maybe I don't want this false. Metrics, I would say none. And then resume, we'll talk about resume in a second. I'll leave that as is for now because that could get pretty long. But let's say you want to do something like, what was one of the other commands that I use fairly often that isn't listed here? Well, let's say you want to change the seed. So the way to do that is everything should be spaced. There should always be spaces around your command. So it would be -- seed. And then this takes in an integer, which is just, you know, a number without a decimal point. So you could set this to 3. Now, you technically don't have to set equals to. You could do this. This works too. For whatever reason, the folks who write the StyleGAN library tend to do this. So I just tend to follow that pattern just to make sure that, like, when I'm copying and pasting things, it's all pretty similar. But this works. One thing to note is that, and I know some folks have run into this issue before, but if you have something that's on your drive or a path that has a space in it, you do want to make sure that space is what we call, it's called what we call escaped. So in some cases, you'll have somewhere it's like sitting on drive. So I believe this is the path to drive. So it's something like /drive/ or my space drive and then / like your folder. The problem with this is that because there's a space here, this argument path assumes this is like a separate command. So it's going to read this as one piece, and then it's going to try and read drive as another argument. I don't know why the folks who decided to mount Google Drive like thought it was a good idea to have a space in here. It's like pure chaos development. But there's 2 things you can do. One is you can wrap it in quotation marks. God, I'm really losing my words today. This works. The other thing, which tends to be what I do, because it's just a little bit more developer-y, is if you do a \, this says whatever character follows this slash is a part of this whole line. So this basically says like, hey, that space belongs as a part of this command. So you will probably see me do this more than likely. One thing I also noticed is that it's a little funky where if you set it as a variable, you need to wrap it in quotes, so it's a string, but you also need to include the escape character, which is just, again, like it just gets really confusing. So if you run into issues where you see something like it says like drive/folder is not recognized, usually that means that your MySpace drive has an issue here. So this is one little trick to keep an eye on. And I would say probably about 25% of the errors that people send me through various classes is because of this. So just be aware of that. But I did just want to show, like, this is how you build up your own command. If you see things that are listed in these variables that you want to play with that aren't listed here, this is how you build up your own command. It's just sort of like, and I literally do it like step by step. I like take the outdoor, fill it out, take the snap, fill it out, take the, so I sort of do it one step at a time. Cool. Any questions about that? Okay. Well, we'll dive back into all of the configurations. Starting with, let's see here, CFG. So as you noticed, developers are lazy and they don't like to type out a lot of letters. So they tend to shorthand everything, which can sometimes lead to like making it really hard to read. CFG stands for config or configuration. Man, I don't know, there's like a ton of stuff to talk about here. Basically, in a StyleGAN paper, you will see that there are many, many different configurations. Each of these are slight modifications to a whole set of other arguments that I'm not talking about here that basically help the model perform to the best of its capabilities based on some things it knows. Now, the NVIDIA folks, when they released this, they said, we have this new auto configuration and it will guess what is the best settings for your model. Just set it to auto and it's great. And in my experience, it has not been great. It does not do what I would like it to do, or like in my experience, like how I would want things set. I may change my mind after like maybe playing with it more. But in general, I would say like I don't love their auto configuration, which is if you don't pass in a configuration, it chooses auto by default. And just talking to other folks, there's also just some question around like, is this really the right way to approach it? What I have done is in my fork, I've specifically set up some additional configurations that I think people in this class might find the most value out of, which is I've set up some things based purely on the size of your GPU. Part of the reason is that if you have a really large GPU, like you can actually rent a P6000 on Paperspace, which is a 24 gigabyte GPU. If you have a larger GPU, you can actually do bigger batch sizes, which is supposed to help with training. I don't think it really matters that much, but it helps a little bit with training. So you can set various values. So I built in some configurations. The one that most people will be using is 11 gigabyte GPU. The reason there's no 16 gigabyte GPU, which is what most GPUs you guys are using for these classes are, is that the value between 11 and 16 is actually the same. So I just set it to be like 11. So you'll probably just want to use 11 gigabyte GPU. There are some other values that you may find if you read through the paper that you might want to play with. This is the actual code in the train.py script. And actually I've added a couple to this since, which I'll talk about in just a minute. So if you're interested in playing with these, or you want to understand what these values are, I can talk through those with you separately. But essentially you'll see here, there's 11 gigabyte, 24 gigabyte, and 48 gigabyte. Not to humble brag, but I do have a 48 gigabyte GPU that I use every once in a while when I'm in a desperate lurch to like do something really quickly. But yeah, so each of these sets up different batch sizes. And these batch sizes are sort of like, they help you train it at different scales. So basically, I would probably recommend, I mean, pretty much everyone will use the 11 gigabyte GPU. It's actually not different from the paper 1024, except for the fact that they assume you have 8 GPUs accessible to you, which pretty much none of us have. So mostly we'll be using, it's basically the same configuration as what is set up in this paper 1024, just converted to working with a single GPU. So if you're interested in that, you can play with these. I'll also, again, happily talk through like what each of these values means. We'll be talking about K-image in a second. So some of these do override, or you can override the configuration to be a custom value. K-image is how long it should train for. 25,000 K-images is like a month of time. None of us will ever hit that value, and nor do we need to. But if you wanted to, you could let it train forever. Yeah, so there's also some other things in here that we could tweak. I might look at tweaking some of these based on other things that I've been playing with. But for now, this is pretty much everything you need to know. And if you're like, I have no idea what you're talking about, Derek, just use 11 gigabyte dash GPU. That's totally fine. Yeah, so like I said, if you have a GPU that's 24 gigabytes or larger, you can use the 24 gigabyte GPU. If you have, though these do assume that you're using a 1024 pixel model. So if you're not using a 1024 model, like if you have a 512 model or something else, let me know and we can create a config for you. I believe all of these do say, actually, I guess they don't, they're not actually tied to a resolution. It's just because this is paper 1024, you do tweak some things a little bit because if you have smaller images, they take up less GPU space. So you can actually increase your batch size a little bit. That's what they're doing here. So if you aren't using 1024, just let me know and we can tweak one of these to work for you. Okay, so there's also a concept of what I would call complex. This is getting kind of in the weeds, but there's a couple little notes inside of the latest NVIDIA paper that says if you have a really complex data set, meaning it's very diverse, they have figured out some special configurations to actually like sort of work with those models better. I'm still in the process of testing those, so I'm not certain how well they work or like if they're guaranteed to be better than just running the default config. But I've added, actually, that's one of the things I've added that isn't here in the screenshot. I've added 2 examples of there's an 11 gigabyte dash GPU dash complex and a 24 gigabyte dash GPU dash complex. And what that complex thing does is it does a couple more arguments inside the model. This is where they actually do change the network a little bit, although really all they're doing is changing some variables within the model. They're not really changing the layers. So this changes the path length to 0, it changes style mixing to none, and it changes the discriminant architecture a little bit. They're basing this on SciFar, which is a large data set of like, I think it's like 10,000 images, but they're 32 pixels by 32 pixels. So like who knows if this would really work, if this is really going to work for 1024 by 1024. I'm just starting to test this, so I'm not sure that it's right just yet. But if you have a really, really diverse data set, like I literally took all the frames from Blade Runner and threw it at this model, which is like pretty insanely diverse, as you can imagine from a film. That has a really high diversity. So this is a case where this might actually work better for that. So I'm testing it. I'm not sure. But if you find that your results are looking very soupy, let's talk and maybe we can play with using this value. One of the things I like about the new model is because it does train much faster. We can do a lot more tests and examples and try things to see if they work better. So I would definitely recommend if you are having issues, let's reach out to Leah or I, maybe come to co-working and we can try and play with some new configurations. Yeah, so just keep that in mind. I would say start with the default and see how it goes. And if you're like not happy with the results and Lee and I are looking at it, we might be able to try the complex configuration and see if that changes anything for us. Yeah, so there is an auto setting. I probably would recommend avoiding it, especially because you're working with us and I can sort of help tweak things as needed. You're welcome to try it and just see what happens, but I generally haven't liked what I've seen so far. All right, so gamma. So this is another thing where if you have too complex of a data set, or if your data set is really noisy, meaning like you just scraped a bunch of stuff and you're not really sure what's in there, there's a lot of people who have said in the past that you can change the gamma value. The default is 10. I believe that's actually set in the config. I see here. Yeah, gamma is set in the config. So you can override that gamma if you want to. The default for most of these is 10. Well, I'm seeing it's really low for sci-fi. So I wonder why that is. But anyway, I've seen some folks have said, whoa, keep going backwards. And in fact, here's a bunch of tweets from someone who I sort of trust on this topic and knows a little bit more about the math side of things than I do. That basically you can increase this value to avoid mode collapse, which we'll talk about in a minute. They increased this value for one of their data sets in StyleGAN2. I believe it was the church data set, which again, churches were just like scraped photographs of churches where they weren't in all the same positions. And they claim that this works better. I've played with this value and I can't say that I can like definitively say that it's better on or off. But again, it's a thing that we could probably tweak. If you're like saying like, oh, I would like to see if I can get better results from this, we can try playing with gamma and see if that does anything. So again, I would definitely recommend just starting with 10 and just sort of see how it goes. And then if we feel like we want to bump it up, we can try bumping it up and see how that goes. K-images. So when you pass in the K-image variable, this just basically says like, at what point should the model stop? And so basically this really only works if you're on Paperspace or on your own GPU, because no matter what you set this to, like I bet you Colab will stop before this stops. So K-image is, I don't know why, but the NVIDIA folks start at like, or say like the max is like 2,500 K-images, which again, will probably take you like a month on a single GPU to train to. In my experience, I've never gotten to that level. I've trained some models for really long times, and I still pretty rarely get up to 2,500 K-images before being like, this is really good. I'm not seeing any changes. Or it's like starting to fall apart and I need to stop the training. So I won't really worry about setting this. You're going to be starting and stopping your machine just based on what you like or don't like, and whatever happens with K-image is going to be fine. Augmentation. So again, I probably wouldn't really recommend messing with this unless you really want to. If you want to turn off augment, what you pass in is in quotes no aug. So if you want to basically train what StyleGAN2 was before ADA, you can do that. By default, augmentation is on, and I recommend it being on. One thing to note is that the paper states that if you get something like over 50,000 images in your data set, augmentation might actually hurt your capabilities of training. I assume no one in this class has a data set that large, so I'm not really going to like say like, make sure you keep an eye on it, but just know that like there is sort of, they find the augmentations work good for small data sets, small being like 1K to 30K. Anything over that size, and you might need to start messing with the probability scores or just turning off augmentations completely. So when they did this with their FFHQ model, which again is 70,000 images mirrored, so 140,000 images total, they found augmentations actually hurt the development of training on those things. So just be aware of that. Again, this probably won't affect anyone in this class. P, so there is a way to set a fixed probability score. The way that probability works inside of the model as it is today is it's actually a fluctuating value. So it actually does some tracking of how your scoring is happening, and it changes the probability value based on that. I, again, probably would not mess with this unless you really know what you're doing. But there is a way if you want to say, like, I only ever want it to always be 0.3. So 30% of the time I want the augmentations to happen. You can set that in here. Most of us won't need to, but just know it's available if you're interested. Target, I kind of have no idea what this thing actually does. I think this allows you to specify a different data set to use your base augmentations off of. Don't hold me to that. I would basically say, like, we probably don't need to worry about this though. But it is an example. It's a parameter in there if you're interested in playing with it or trying to figure out what it does. And lastly, augpipe. This one I actually think we might end up using more often than I would say we are frequently using. Augpipe determines what augmentations we're actually applying to the images. In my experience, this is a case of where leakage occurs, and a fix to do this is to change what augmentations are available to this. We'll talk about this more when we can show into, like, keep an eye on what you're looking on what to watch for. This is a list of all of the augmentation specifications. So if you do -- augpipe equals and then pass in one of these values, these are the changes that are being applied. So one thing to note is that it doesn't do any Y flipping, which I'm kind of intrigued by. I might actually add that into a to-do list for me. But right now it just sort of assumes you're only doing X flipping in most cases. There's also a note in here. This is a graphic from the paper. It's a little hard to read, but when you read through the paper, it might make more sense. But basically, like, each of these colored lines is a different augmentation type. So there's blit, geom, color, filter, noise, cutout. And then each of these is when they apply them individually to a data set, how it affected the FID score. So again, the FID score is sort of a placeholder for, you know, how realistic are these things. The big thing to note is that the blit and geometry by far are the most important things to use. Color sometimes affects score as well, and sometimes it doesn't. And the other ones are honestly, like, they added them, but they sort of said, like, you don't really need to use these. So by default, the augpipe they use is BGC. So that's blit, geometry, and color. And that just sort of is based on the testing they've done. Now, what I have found is actually adding in color has a tendency in the data sets that I have to introduce a lot of color artifacts. So in some cases, I'm actually removing C, in which case I'm just using augpipe equals BG. And I find that that is much better for my color. We'll talk about that more when we get to leakage. But just know that, like, if you turn on all of these, BGC, FNC, they basically say, like, don't expect this to be better. But who knows? For your data set, it might be. Again, this is a place of where, like, we could probably experiment for, like, the next year and, like, learn a lot of stuff about our individual data sets using these different parameters. I'm always defaulting to what they learned, and sort of, like, if I find it's going in a different way, I might change it. But just know that, like, there are a ton of options in here, and I might even get crazy and try to add some more, but we'll sort of see how that goes. C method, I really have no idea what this is. I think it has to do with testing. I'm going to skip it because we're running low on time, and unless someone really wants to figure out how to do a really strong testing pipeline, we can just skip this. Same with DC cap. I have no idea what this means. I tried to figure out it from, this is literally the quote from the help, and I have no idea what that means. Resume. So this is the one you will probably use almost always because we are going to do transfer learning in this class, because transfer learning saves us a ton of time, and it is much better if we use transfer learning. So resume. So in some cases, when we first start our model for the very first time, let me see if I have a slide here for this. Yes, so if you are starting a model from the very beginning, you should use a thing that is like, I think it's in quotations, it's FFHQ 1024. If you're using a 1024 by 1024 model, if you're using a 512 model, you should use FFHQ 512. That is going to transfer learn, which I will talk about in just a minute to explain what that is, from FFHQ. And that will basically save us a little bit of time in training. If you are resuming, especially for folks on Colab, if your Colab machine is shut down and you want to restart, what you're going to pass into that resume file is your path to your latest pickle file. So when you're finished training in Colab, there'll be a bunch of files inside of your Google Drive based on your latest run. You'll find the pickle file path in there, and you'll put that into resume. I will cover that in the video on Colab. If that is confusing to you right now, I promise I will cover that. But this is basically how you will pick up and continue your training on Colab. So this one will be pretty important, and it's pretty, you just have to remember, like, once you get the hang of it, it's pretty easy, but just know that. Okay, so let's talk, I believe this is the last, oh, there's this other thing called freeze D. We don't really need to worry about this. This is, when you do transfer learning, there is some concept of freezing layers of discriminator. I don't think we need to do that for this class or for GANs in general. I just haven't found it's necessary. But if you've heard about freezing layers of discriminator before and you want to play with it, I'm happy to talk through it. But for now, we don't need to worry about it. Let's talk a little about transfer learning. For those of you who haven't done transfer learning, either in my runway class or in other classes before, this can feel a little weird. The idea of transfer learning is that you are basically picking up a model that has already been what we call pre-trained, and you are taking most of the learning that has already been done in there and applying it to your own data set. In most cases with StyleGAN, we use FFHQ as our transfer learn data set, just because the NVIDIA folks trained it for like a really long time and it's pretty good. And it tends to work for just about any data set we want to transfer from. So when you first run your training on Colab or on Paperspace, your very first fakes file will look like this. It will always look like faces. And people are always like, why am I seeing faces? I have a data set that isn't faces. What's going on here? And basically like what's happening is it's starting with your transfer learn model, and it will slowly move to your new model. So what that looks like is something like this. Come on. So as you see, it basically starts with faces. The faces slowly disappear until we get to my abstract data set. Now, this will only take maybe, a couple hours to move from faces to your new data set. But just know that like over time, you will have this experience of like things are sort of like moving away from faces. And there's always this very creepy sort of moment here where it's like a mix of your faces and or a mix of faces and like whatever you're working on. Some people really love that and like play with it, and like that is like the model they have and they generate images from. For others, it's just sort of like a step and you just like sort of throw it away when it's produced. So, but just know that, like this is transfer learning. I have always, this is like the one thing where like I told you so moments with machine learning people. I have always been a strong proponent of transfer learning because one, it saves us time, and I believe the pushback has always been like, well, you should transfer learn from a domain that is similar. Meaning, if you're doing faces, you should transfer from faces. If you're doing abstraction, you should transfer from other abstractions. The NVIDIA folks in their paper, there's like one line of text that says it doesn't actually matter. Transfer learning works better. No matter what, transfer learning works better no matter what than training from scratch, which is pretty conceptually interesting. I have some theories about why that is. Essentially, like what I think is happening is if you're looking at a data set that has been trained on faces, this has gone through a very complex process of trying to generate, like learning how to make images and learning how to make faces. And even though it's learning to make faces, it has also learned a bunch of other things about imagery as a whole. So when you transfer learn from that, you're taking all of those sort of internal knowledge about how to generate images and taking that transfer and applying it to a new method or to a new domain. And that means that in general, like you're learning twice as much. It doesn't really happen like it's twice as much. It's just like, it's almost like 1.1 times as much. And NVIDIA, in fact, did some testing with this and found that FID scores when transfer learned are actually better than when trained from scratch. So if anyone tells you like, oh, you shouldn't be doing transfer learning or like you shouldn't be transfer learning off of FHQ, they are wrong. The paper says otherwise, and it is totally fine to do transfer learning. A lot of people feel like it's cheating or something, and it's not at all. It saves you time, it saves you money, and it actually is better. So like all three of those things mean you should do it. Now you can actually transfer learn off of your own paper or off your own model if you want to. So like, let's say like I trained this model, which is this abstract image model. Let's say I transfer learned off FHQ. My next data set is like, let's say something else, like maybe it's cars, and I want to transfer learn. I could transfer learn cars off of faces if I wanted to, or I could transfer cars off of this model. I don't think there's anything like you build, if you like transfer learn off of like something that's been transfer learned off of 50 other transfer learning sets, that it's like that much smarter. I don't think it works that well. It's like very small increments of updates, but you can do that. And one of the reasons why you might want to do that is this sort of fun in between steps. can also become really interesting parts of your artwork, right? So if you take a car and you take a car model and you transfer learn off of geometry or like these weird geometric shapes, you get nice, interesting in between steps, right? So if you are not interested in just like weird, creepy faces, but you want to create other things that are what I've called mixed model or mixed blending models, you can do that. There's also notebooks out there, which I might cover a little bit next week, about how to do network blending, which is literally taking the weights of two different models and being able to interpolate between the two of them. Usually those work better if you are transfer learning off of a model. So if you have two models, A and B, Naoko, you heard this earlier today, but if you are trying to do a network blend between A and B, B should be transfer learned off of A. It is far more likely that a network blend will work well if you do that transfer learning off of each other. Lots of little mathematic reasons for why that is, but that's another reason why you might want to do transfer learning off of your own artwork or off your own trained data sets. And the way to do that is, again, to just pass in the pickle value of like your latest model into the resume function. So when you're first doing that car model, you give it the resume pickle file of your abstract geometry. That is basically how you do transfer learning. It's pretty crazy that it's that easy, but it is really that easy. Okay, that is all the training parameters, and like, holy crap, that was almost the entire class. We might run a little bit late, sorry folks. I thought this would be shorter, and of course it isn't, because I just like went on weird rails. So let's talk a little bit about actually what happens during the training process, and then Leah is going to cover some of the pitfalls and things to avoid. So while training, you will have a folder generated that looks something like this. Now, actually, for the new model, you won't have any in-between fakes. You'll just have a fake that corresponds directly to a snapshot. So, but what happens in these folders is you get a fake image with a value. For now, this will probably be something like 0032 or 00 whatever. And then a network snapshot that has the same value. And what these two things are is the pickle file is actually your model weights. So you don't really want to delete these, or like you can delete ones you know you don't like, but don't delete them if you like the results of them. So these actually contain the weights of them. These files are about 370 megabytes per file, so they do get pretty large. So, you know, here's a case where you might want to start pruning these after a little bit of training, just to sort of see what you get. But in general, like this is also why we said like get a 2 terabyte Google Drive account, and then you can just fill it up and like delete stuff at your leisure. But the pickle files are the model weights. So it's important to remember, like, this is what you're going to often reference to generate images from, to resume training from, those sort of things. This is really the important, like, sort of math bits that we want to keep. These fake files are the generated fake files from this model. So if you look at 491 and you're like, I don't like what's going on in the faces here, then you also won't really like 491 as the model file. So the fakes are just sort of like a generated snapshot of what you see in that model file. Yes, does that make sense? Okay, I don't see anyone saying no. So I will assume that makes sense. This will be most of what is in your folder. Now, if you do run metrics, there will also be a metric with the name of whatever the metric is and a txt file. This txt file will contain basically every one of these intervals. It'll contain a sort of a numeric sort of K image and then the value for the score. So you might open this file and you'll see at 10,483, you have a score of 50. And at 10,491, you have a score of 45. Again, that might indicate that Pickle 491 is better, but I would look at them and make sure, like judge by eye, not by what the FID score is. Whew, okay, Leah, I'm gonna turn it over to you.
Sure, yeah. Let me share my screen. Cool, so I'm gonna go over today like things you should watch out for when you're training, because you might like, yeah, you might go through all this trouble training stuff and then you might not get results that you like, and there are a couple of reasons why. I'm going to go through 4 of them today. The first of which is something called overfitting. This is when you're like, you might get images that are output and then be like, oh, these images don't look like new. Like they look kind of exactly like images from my data set that I input to it. So what is happening here and what's going on is when this means your model is essentially just memorizing your training data set. So like maybe you might give it a data set of like 1,000 images and it knows exactly like, okay, if I generate an image that looks almost exactly like this one image from your training data set, I know I can fool the discriminator. And yeah, conceptually, this is sort of what's going on when overfitting happens. Overfitting is this thing on the right. So like, let's say, this is more in the example of like a classifier network where you're trying to like separate these X's and these circles. But overfitting is when your model essentially like memorizes the boundary between like your in your training data. And then underfitting, which is the opposite of overfitting, is when it sort of oversimplifies. But overfitting is when it's like pretty much like memorizing the border of your training data distribution and being like, okay, I'm going to exactly fit to this one example from the training set. And so this is how it might actually manifest in your StyleGAN training. I'll let these videos play. So as you can see, the thing on the right is an example of what you want, because there's sort of like a smooth transition between each of the faces. But this thing on the left, which Derek trained on these images of like TVs and phones, it's not very smooth, it's very jumpy. And that's because the model itself and its latent space is not learning like a smooth interpolation between like this TV and this TV. It's learning like, I know this one and I know this one, but I don't really know that much about like the structure in between. And that's why when you do a latent space interpolation on a model that has overfitting, it's like really jumpy. And yeah, in general, overfitting is like, it's not terrible for art, but it's also not great. And this is because it's literally sort of just spitting out what you fed it in your original data set. So it is kind of like going through this very expensive and arduous process to sort of just get back what you fed it to it. Here is an example of overfitting again, but in like this grid of fakes. So you can see like there are a lot of similar images, like this rainbow TV thing appears a lot of times. And yeah, there are a couple things that appear like repeatedly, and there's not a lot of like general diversity. There are only a couple of examples that appear a lot. So this can happen for a variety of reasons. Generally, it's because your data set is not diverse enough or not large enough or contains a lot of duplicates. So what you can do in these cases is add more images to your data set, add more diversity to your data set. You could also augment your data set and also play with that gamma value. The second thing you should watch out for is mode collapse. This might come out like if you have a data set that is of animals, of cats and dogs, and your model only generates dogs. And like to the GAN, this is a totally acceptable output because like if it's generating dogs, then yeah, those dogs look realistic and they look like things from the training data set. But to you, that might not be what you want because you also fed it this whole other like area of the training distribution covered with cats. And so what is going on here is when the generator finds a couple of solutions that fool the discriminator, and like it sort of hones in on those couple solutions, but it doesn't cover the space of like all possible solutions that you fed it, or all possible like areas of data that you fed it. So what this looks like is here, this thing on the left is mode collapse, because you have all of these different areas of your training data. And you know, the generator has learned, okay, I know if I just generate stuff in this area, it fools the discriminator and I do a good job. Whereas this thing on the right, this is more of what we want because we want like good coverage of our entire training data set. So this is an example of the latest StyleGAN-ADA and an example of what Derek suspects is mode collapse. I think, Derek, these magenta boxes, they all have this similar type of flower. It looks kind of like a poppy. And they're all sort of this similar type of flower. And then, so that's one example of mode collapse. And then these teal ones, they have these sort of, oops, pretty like fluttery types of flowers.
Yeah, so what I'm seeing here is actually the structure underlining it. So if you actually, you can almost count the flowers, right? So in all the blue ones, there's these 4 and smaller ones in the top corner, and then one bigger one sort of in the same position. And in all the magenta ones, there's these like cluster line of 5 or 6 images. And even though they're different colors, they're all sort of like in the exact same position. I've actually not seen this previously, but I think this might be an example of mode collapse where like the mode collapse is not actually like flower colors, but actually just flower structures. So I actually want to play with this one and more and see and figure out what's actually going on. But yeah, I don't, mode collapse is also kind of hard to figure out with GANs because when you're generating images, like you might be like, that looks real, cool, like that's awesome. But like if you start to notice patterns where like, oh, all the images are appearing in the same place, or like this particular thing is showing up more often than other things, I think that's an example of mode collapse. I can't really be sure, to be honest, though.
Yeah, generally, like when you're generating stuff, you want things that have good diversity. Like I think like between these two as well, they have a similar overall structure too. So the things you can do is you can alter the learning rate, which was in that config argument we talked about earlier, and double the batch size. The batch size is how much, like basically through each training pass, the model will look at some subset of your data set because it can't, or like often you don't have enough compute power or like don't want to take the entire time to look through the entire data set. So the batch size is how much of what subset of your data is passing through your model on each tick. So things you can do are like double that so that it gets a wider variation of the data every time it does a tick, or you can alter the training rate. The third thing you should watch out for is gradient explosion. This is a pretty common problem to all deep neural networks, gradient explosion. It is when the training sort of like goes on a run and sort of finds this one area that's very, very unstable and very chaotic. This is what it might manifest as in your actual StyleGAN model. You'll get these things that, I don't know, are very noisy and look kind of, I don't know, shattered and jagged. Here's another example. Yeah, and so it's just very noisy and chaotic. The reason why it's called exploding gradients is because, yeah, don't want to get too much into the weeds, but like networks sort of, the way they train is they minimize an overall loss, which is like a score of like how bad they did. And the method they use to sort of minimize the loss is, you can imagine the loss as this sort of terrain, like, and it's trying to find like the lowest point, like the valley in this area. And it uses this thing called stochastic gradient descent, which basically tells it, it's like a process that tells it, okay, move in this direction, which will lead you to the lowest valley. And what happens in the case of exploding gradients is that the steps it's taking to like step down to the minimum, like the valley, is the steps it's taking are actually like really large, and it will end up sort of bouncing around a lot and being unstable. So on each step of like back propagation, in the case of an exploding gradient problem, your weights might change like very drastically from each tick to tick. So things you can do in the case that you're getting like these very noisy, weird results is you can restart from a previous good pickle. This is basically transfer learning. So you'll go back into your generated pickles and fakes and then pick the previous good one. We generally recommend actually going like 2 steps back just to be safe. You can also, as in the case of mode collapse, you can alter the learning rate and then also increase the size of your batches. And then the fourth thing to be careful about, this is specific to StyleGAN-ADA, because StyleGAN-ADA is the one with all of these new augmentations built into it. These are when the augmentations actually come out and like leak into your outputted generated images. So here are some examples. Derek, I think you mentioned that these are the color augmentations sort of coming out in your outputs.
Yeah, so in this case, on the left side of each of these is my real data set. And on the right is what's happening in terms of the fakes. So in this case, I believe this is what's called a luma flip. I believe that in color, there's a thing called luma or luminance flipping. And I believe that what you're seeing here is that, where it's basically like the background is flipping, but it still kind of looks realistic. And like you can kind of see why this would fake out the discriminator, right? Because if it's just looking for like edges or textures or even colors, it's kind of like, yeah, this looks close enough. Like even though the background is dark, I believe these shapes are still flower-like. So I think it's like, yeah, I'm not really sure what's going on here, but it's definitely like a case where like I can see why the discriminator would be fooled, but it's also clearly not right. Yeah, and this is an example again, reals on the left and fakes are on the right, where it clearly like is over indexing toward purples. There's a lot of green in the actual data set, and you don't see any green here. You see way more purple. And same with this one. You know, I'm just seeing a lot of like this whole thing is more green hue, although you can see where like some of it is coming through a little bit, or sorry, purple hue. God, I'm not colorblind. I just am not using words right today. So yeah, I've seen this. I mean, I ran this on 6 or 7 data sets and I saw it on half of them. So clearly there's something going on here. Matt and I were talking about this earlier, but I think because the NVIDIA folks are training these mostly on photographs and on faces, I bet there's less of an issue with color leakage because it probably like knows what a photograph is supposed to look like and it is kind of veering toward that. Whereas my data sets, which are more illustrative and more abstract, it's probably like not really able to figure out color as well. So I'm definitely seeing leakage in some of my data sets.
Yeah, so since these leakages of the augmentations are caused by the augmentations, things you can do is you can remove the augmentation method from the --aug pipe argument. Like I think Derek mentioned earlier that he removed the color one because he was seeing these colors coming through. And you can also lower the --p value. This is the probability that an augmentation is applied.
Yeah, for this, I would probably start with the aug pipe and then go from there. Because you don't really want to mess with the p-value because it's technically variable. So I'd start with aug pipe. So that's what I did for those data sets. I actually just removed the color. So I think it's BGC is the default, and I just changed it to BG. And I'm getting much better results with that. So let's say keep an eye on it, and it might happen to yours. The good thing about these 4 methods is I think in general, except for leakage, it should be better with StyleGAN2-ADA than previous versions. I mean, I saw a lot of these things happen, especially in StyleGAN1. StyleGAN1, it was sort of like a crapshoot. Like, I felt like 30% of the time I would get something going wrong. And I see it a lot less now in the latest version. So hopefully it happens a lot less to you. But if it does happen to you, like just reach out to Leah and I, we can probably sort of like come up with some ideas on how to change it for the next round of training.
Okay, and then just to round off the class I'll give you a rundown of like how to decide which iteration is best. So when you get a grid of fakes, one thing some people might do is they might pull up things that are very close in tick value, like this 2260, 2350, 2570, and 2660, and then try to compare between these, which are all pretty close in terms of like the tick values, and then be like, oh, I like this one slightly more than this one, therefore this pickle file or this model file overall is better than this one. Don't do that. What you should do instead is compare tick values that are farther apart. So this one's 990 and 2040, 4080, and 5140, because you should keep in mind that between each of these, it's doing like an updating of all the weights, and it's sort of it is like a slow process where, you know, it is converging. And so the amount that things change between in this small number of ticks is like not that representative of the overall like structure of that model. And then on a greater scale of like maybe 1,000 ticks or so, you'll be able to see more like what is actually the general trend of how the model is generating things overall. And one thing you should also keep in mind is that every single one of these is a random seed, and it's just a sample from that latent space of your model. So it's literally just picking, I don't know, like 20 or 25 random points in the entire space and then generating them to you. So it's possible, like just because you like maybe this one picture, that doesn't mean that that represents your overall model. You should be looking at this entire thing, this entire grid as a whole, as like a sample of the latent space of your model as a whole, and then pick which model you like best based off of like the entire grid as a whole.
Yeah, so just to add to this, I used to say you should look about between every 500K images, which would be something similar to this. This is actually maybe 1,000K images between each setting. The new models train a lot faster, so it's almost like not, I wouldn't worry about as much about the numbers and just like realize that like pickles next to each other are maybe like you shouldn't be comparing. It's almost like when you go to the eye doctor and there's big jumps and there's little jumps, and like the big jumps are pretty much more important than the little jumps, although you feel like you're being tested. Where like if you look at two pickle files right next to each other, if trying to choose between those is really hard. Whereas if you look for stuff that's spaced out a little bit more, it is a little bit easier to pick from and just sort of maybe say like, oh, this feels better in general, for the exact same reasons Leah mentioned. But because the new model converges so much faster, these numbers might be slightly off. So I would say, you know, like look between every like 50K images rather than like every 500 or whatever. So yeah, just keep that in mind. But I would say like a lot of times people are like, which ones do I choose? Or like almost like paralysis by choice of like, I love all of these, which ones do I work with? And it's like, if that's the case, probably just work with the latest one you have. Like the idea is that after a period of time, like training should stabilize and like your latest training should ideally be the best version. It's not always the case. And this is a case where maybe metrics are actually helpful, is you can sort of say, well, like between these three, which one has the best metric? Okay, I guess I'll go with this one then. Is a really challenging thing. And there's no like clear solution like there are with like classifier networks where like the scoring is like really accurate. It's definitely like more the artistic eye. And I think, you know, some people lean toward really early stuff where like maybe there's still a little bit of face texture or just face shapes. And then there's later ones that are really like almost realistic. And then other people are like, I don't really like realism. I want something in between these two and like that sort of thing. So it's kind of an artistic process to figure out what you want. But I also say like, don't try to pick between two pickles right next to each other. It's really hard to do that.
Do you guys have any questions so far? Or yeah, I guess that is the end of today's class. So any questions about what we talked about today?
So I'll just say one thing, which is like, we probably threw a lot at you, right? You're starting to wonder like, should I be changing my configuration? Should I be changing these values? I would start with like the most basic defaults you can, which would be like your data set, the basic configuration of 11 gigabyte GPU. Like start with that and just see if you get good results. If you get good results, then like, that's great. Like that's probably enough. If you like get results where you're like, I wish I could do more like this, or like, can I get more of this sort of thing in here? Then it can be a conversation between Leah, I, and yourself, like to figure out how to tweak things. So like, again, it can feel really overwhelming and be like, there's so many options. Where do I start? Start with the most basic stuff. Like, don't overthink it, just do it. Also, like a lot of people are like, oh, I don't want to like waste too much time training. Like if it's going to be wrong, it's like, you have to learn if it's wrong before you even get started. So start somewhere, start with the most basic stuff and build up from there. Don't overthink it. Don't wait too long to train it. Just start training.
I guess I have a question. Have you played around with the projector at all with this StyleGAN? And like, because yeah, I'm just imagining you could have this sort of holdout set of images where you haven't included them in the training set, and you could kind of see like how well is it projecting those holdout set images. Like, have you tried something like that? And also just like how long does that take? How long does it take to project one thing?
I haven't done anything in projecting in terms of this data set or like the newest model. we've done a lot with Lee and I have done a bunch with projection in previous classes, and there are some videos. Sorry. Okay. But there are other. We've done some projection in other models using StyleGAN2. So I think agreed. Like I think that's an interesting idea to just sort of like check and see if there are. To hold out a test data set, see if it shows up in projection. I think projection is a little bit of a weird. It's a little weird, and I think people like. I think it's been billed in the past as like a way to find fakes or to see if this image is in your data set. In my experience, it's not that easy. And there are like different techniques. There's a projector, there's an encoder, there's other things where you can put your image in there, and like an encoder will basically like embed a real image in your data set and tell you like where it is. You can't do much once it's in there, but you can do it. So there's different things that you can play with. But I would say like projection is worth exploring. And we've got a notebook. I can probably hook it up to work for StyleGAN2-ADA for anyone that's interested. And it's worth playing with to just sort of see how it works. It is a really cool process. And I don't do as much of it as I probably should, just because I'm busy training models and things. But I think it's definitely worth something to see more people explore. So yeah.
Yeah, I'd be super interested in that. Thanks.
Yeah, of course. So for next week, I think it would be great if everyone just started training models. And if you can make it to co-working sessions, like it's a good time to show up and just sort of say like, here's what I'm working on. Here's what my current outputs look like. Like, is this good? Is it bad? Like, what should we play with? It's also a good time. Like, you also, if for whatever reason you can't make a co-working session, just like DM Lear and I, we can probably set up a little bit of time just to like check in with with you as well. Happy to do that. So yeah, I would say like just start training stuff. One thing that is like really nice is like, because this is faster, you can hopefully train more than one data set, or you can train a data set and then do another one with some different configurations and sort of keep track of things. I do think that I'm not the best at keeping notes, but I do think like a notebook of like, tried this on this data set, didn't work, is a good scientific method. I'm bad at doing that myself. I try to keep it all up here, which never really ever works. But if that's sort of the type of person you are, you might want to do that. Just keeping track of notes. And it'll say like, one thing that we talked about for show and tell is also just like showing what you experimented with. I think a lot of times people are like, oh, I want to show something really cool in show and tell. And like, that is certainly valuable, but also saying like, I found that for my data set, these configurations work best. Like people will be very, very interested in that and those details as well. So you can sort of approach this from like a scientific method perspective or from like an artistic method, and both are totally valid. And I would recommend that you do both of those things in either a show and tell perspective, or, I used to push people like publish stuff on Medium or publish stuff on your blog. And while I don't push people as much on that because I think these are much shorter classes and it's harder to do that, I still think there's a lot of value in doing those things. I've learned a lot from just having other people publish what their StyleGAN results were and how they tweak things. And a lot of that learning has been taken into this class. So like the gamma values and other things. So I would definitely encourage you, if you have interesting results or things you've learned, to just write them up and publish them somewhere. Any other questions before we wrap up for the day? Cool. So I will add our slides to the class notes, basically like right after we finish up class here. The video is usually done in an hour or two. The paper space demo is already up for those of you who want to walk through that. The collab notebook already exists. I will record a video for that probably tomorrow night. So if anyone is looking for more of a video walkthrough, I'll make sure that that's available to people as well. But hopefully the notes in the notebook make enough sense to get started. So if you have any other questions, just drop a note in the Slack channel and Lee and I can respond there. And otherwise, hopefully we'll see folks in co-working session, and we'll follow up more with more details about show and tell and that sort of thing this week as well. Cool. All right. We'll see everybody in the next couple of days, hopefully, and we'll talk on Slack soon.
Derek, just want to, I closed the paper space.
Yes.
The window and reopened it, and it worked fine.
I had that exact same experience, and I don't know why that is. It's something funky to do with paper space, but glad to hear it's working now. So cool.
Thank you.
And take a look at that video. And if that video, if you have any questions about that video, let me know.
Sure. Thank you very much.
Of course. Okay. All right. See everybody on Slack, and then hopefully for sure next week. Okay. Bye, everybody.
Bye, everybody.